Hello everyone, my name is George Alanis with Eberspaecher Climate Control Systems. Thank you all for joining this webinar. This webinar will focus on the third generation Hydronic S3 heaters and should be considered as a basic level training which will provide you with all information on the product and scope of applications. Although we may mention that this webinar will not cover in-depth information on the installation, diagnostics, troubleshooting, or repairs. These topics will be covered in later webinars. So as you all know, the Hydronic S3 third generation heater is one of our newest heaters. This is what basically kick-started the next generation heaters, if you may, in our product line. So during this webinar, we are going to learn or discuss a lot of information about this heaters, including features, identification, specifications. We are also going to take a look at the heater parts and function. We will briefly review the heater operational phases, the control switch options that can be used along with this heater, the current heater kits that are available, and finally we'll end the webinar session with some basic warranty information and also more importantly, the pre-season maintenance and service recommendations. So moving on to the next slide, here we have all the features of this Hydronic S3 third generation heater listed. This heater was built from the ground up completely. So there was a total change in design if you compare it to any of the previous generation heaters. So as you can see, if you move in a clockwise direction over here, we begin with the blower motor. So this motor now is completely encapsulated, which means it's well protected from dust and dirt and debris, which would otherwise affect the service life of the fan assembly and the motor itself. So having it totally encapsulated and isolated from the combustion air that's coming in helps extend the service life. All of the electrical interfaces are very similar to the previous generation heater, with the exception now that this heater is also using the CAN bus protocol for communication, not only with diagnostics, but also with the controller also. Just like the second generation Airtronic that we discussed this week, this heater also has the S Plus signal that can be used to activate the heater. And this allows for those customers who would prefer to use a non-CAN style interface to control the heater. Just like in the past, this heater also has the analog output, which could be used to have additional functions simultaneously when the heater is in operation. This could include the HVAC or valve controls. The design of this heater has taken into account a thermal decoupling of the electrical components, and this is in order to separate the cold parts from the hot parts as much as you can and insulate them so as to improve the efficiency, especially of the fan, and also increase the overall heater lifetime. One of the biggest changes which has happened inside the heater is the introduction of the sheet metal burning chamber. The primary purpose in moving in this direction was to reduce the cost of the heater, but at the same time, we were well aware that having a sheet metal burning chamber can be challenging. So the design part of it took into account all of the negative points that would happen if you use a sheet metal burning chamber, and then they reinforced it and made it a better design, if you may. Our competition heater uses sheet metal burning chambers for a very long time, but even now, if you were to compare the competition heater burn chamber versus ours, you'll find there's a huge improvement over theirs. One of the new functions that has now been introduced, and we mentioned this during our Easy Start Pro controller webinar, is the residual heat function. This is totally new function. It basically utilizes the residual heat in the system, and then basically that can be used, and then once in order to add on to the main heating function. The other thing that has been introduced with the Hydronic S3 heater is the fact that now the coolant pump itself is controlled. By default from the factory, it is set to a controlled coolant pump option. But then this option can be switched off or on by the customer using the Easy Scan diagnostics. Having a controlled or regulated coolant pump allows for a much quicker heating of the coolant, and also reduces the power consumption. And in some critical applications, this could be very useful, especially in the passenger car segment, where there is a shorter drive time versus heating time. Just like in the Electronic second generation, CAN bus protocol is the new common platform, and this would be the norm moving forward for all future generations of heaters. Having the CAN bus protocol greatly increases or enhances the diagnostic and functionality of the heater. We have better response time. We are able to, connect multiple devices at the same time, etc. And the communication speed is faster. High altitude compensation. This is not completely introduced into the heater as such, and we will discuss this more as we go along in this webinar session. The high altitude compensation is only fully automatic in the 24-volt CS version of the Hydronic S3 heater. In the 12-volt version, the CS version of the heater, high altitude compensation is achieved through the Easy Start Pro by using the high altitude function on the controller. But we will discuss this more as we move along with the presentation. Like with every coolant heater, yes, it has an inlet and outlet coolant port. The kit comes with both the straight and bent type, so the customer can choose which is preferred. And these are fully rotatable so as to allow for an ease of installation. Just like the Electronic 2 heater, the heater ECU is our own development, and it's an in-house assembly. This allows us to keep the cost down, maintain the quality levels, and also we are able to lower the lead time required to make any kind of changes. Just like the Electronic heater, on this heater also the ECU makes a direct contact to the fan or the motor, so there is no internal harnesses or terminals, etc., which could be a failure point. So by eliminating that, we are actually increasing the reliability of this heater. Because of the encapsulated motor, this heater now has a much higher protection class rating. As you can see, it has the maximum 5K, 6K protection with the blower running, and without the blower running, it's even more higher. And with both these protection classes, in fact, the one with the higher protection class, the 9K protection class, it can even resist steam cleaning should that ever happen in the field. So overall, it's well protected in comparison to any of our older generation heaters. And then finally, we have the brushless motor, which increases the service life of the unit itself, but also we have much better improved combustion values during operation of the heater. So now let's take a look at some of the specifications of the new Hydronic S3 heater. And To compare, we have also shown the first generation heater, so we can see what exactly has changed and what has not changed. So column number 2 shows us the first generation heater. Column number 3 and 4 basically shows us the Hydronic S3 heater. The only difference being column number 3 shows us the CL version of the heater, and column number 4 shows us the CS version of the heater. We will discuss what CL and CS means later on when we talk about heater nomenclature. So from a heat output standpoint, you will see in the diesel variant of the heater, the maximum output of the heater still remains the same for the 12-volt heater. When you compare the 12-volt heater first generation versus the third generation, maximum output is exactly the same, both for the diesel and the gasoline variants. What has changed is the minimum output. As you can see in the diesel variant, in the first generation, we had 2.4 kilowatt as the minimum, whereas now in the Hydronic S3, we have dropped it down to 1.3 kilowatt. There is a reason for doing that, and we'll explain that later when we talk about differences. In the gasoline version, there is a marginal change. Before it was a minimum 1.5 kilowatt, that has been increased to 1.8 kilowatt. So apart from these changes, minor changes in the minimums, the maximum output of the heater has been maintained. The next row shows us the controlling of the heating output. In the first generation heater, yes, we had only 2 stages of operation, whereas now the Hydronic S3 is completely stageless or variable output, and this is achievable due to the brushless motor. High altitude capability. We mentioned this in the previous slide. First generation, the maximum elevation that these units could be operated was 1,500 meters, which is approximately 5,000 feet. But if you add to operate them above 5,000 feet, then the first generation heaters could be coupled with what we call as high altitude sensors to achieve that. In the third generation heater, you will see between the CL and the CS, it's only the CS version of the heater that can be operated in excess of 1,500 meters manually by using the Easy Start Pro controller, whereas that's not possible with the CL version of the heater. The CL version of the heater, the maximum elevation possible is 1,500 meters or 5,000 feet, whereas with the Easy Start Pro, the CS version of the heater can be operated up to almost twice as much, which is about 10,000 feet. From the dimensions, the footprint of the heater, you will see they are very comparable, pretty much almost the same size in a way. And of course, the electrical interfaces has been modified to incorporate the CAN bus communication. And as you can see, the CL version utilizes CAN only for diagnostics, whereas the CS version uses CAN for diagnostics and as well as for communication with other devices like the controllers or any other auxiliary device that can be connected to the heater. So there is a change, there's a difference between the CL and the CS versions, as you can see. What is also important is, as I pointed out before, the S Plus option has been retained, but only in the CS version of the heater, which means the Hydronic S3 12-volt economy series CS version heater can be switched on by using an S Plus signal, which is a 12 plus or a 12 volt or a 24 volt signal. But again, this option is not available in the CL version, so which means you cannot use a 12 volt or 24 volt signal to activate this heater. We already know this, the motor type is now brushless on the new version of the heaters compared to the first generation. And from the acoustics point of view, you can see this heater has far better acoustics, and this is all achieved due to a much better burning principle. We have now a variable output, so the heater doesn't have to switch between, like, for example, high and low and medium, etc. The fuel pump has been modified to make it a whole lot quieter, and of course the stageless control. So all of this goes towards achieving a much more quieter operational noise. The lifetime of the heater is about 3,000 hours. That's what's officially stated, but I would say it can go all the way up to now 5,000 hours, because now we have a totally encapsulated motor and also a brushless motor. And then of course we have the residual heat function. This is only in the 12 volt CS version of the heater. None of the other heaters have it. And then finally, the operating devices that can be used with the heaters. So we can see the Easy Start Pro controller is the one that would be used with the Hydronic S3 12 volt economy CS version of the heater, whereas the CL version is not compatible with the Easy Start Pro at all. And the reason for that is because the Easy Start Pro operates totally on CAN bus, whereas, as you can see, the CAN bus on the CL version of the heater is only limited for diagnostics. So the option then becomes using the LIN communication, which is basically provided for by the Easy Start timer. And also, it does not have an S plus signal, so there is no option to use any other controller besides the Easy Start timer. Now, yes, we do have something called as a Wi-Fi controller as an option. If you look up the partner portal, you will see that as an option. It's available, and that controller can communicate with the heater, but it's a third-party controller, but we do have it available. First generation heaters, as you can see, was only possible using LIN or the S plus signal. So this is an overview of the specifications of the Hydronic S3 heater, the 12 volt series. When we look at the 24 volt version of these heaters, again, and we compare it with the previous generation 24 volt heaters, yes, it is very similar. Once again, the output has been modified now, both on the minimum side as well as the maximum side as well. So you can see it's a 5.6 kilowatts instead of just 5 kilowatts. Yes, the output control is now stageless or variable output in comparison to the first generation. And then here's the significant difference, is that the 24 volt version of this heater, Hydronic S3 heater, now comes built in with the automatic high altitude compensation. This is very similar to what we find in our second generation Electronic heaters. So that's been carried forward to this heaters as well. Dimension wise, they are very much similar. And then from the electrical interface, yes, we have the new CAN protocol introduction. And at the same time, we have retained the S plus component, so as to allow customers to operate the heater using a simple 24 volt signal. What is not available on the 24 volt heater is the ability to communicate over LIN, so that's been removed totally. The motor itself is now brushless compared to the brushed motor we had before. And on the 24 volt heater, as you can see, they have listed 5,000 hours as the lifetime. That's the maximum. And everything else about the heater is very much the same from the prospect of sound, better acoustics. You can see it's basically the same as the 12 volt version of the S3 heater. And then once again, from the operating devices, the Easy Start Pro is the compatible operating device for the Hydronic S3 24 volt commercial version of the heater. So just like we saw with the Hydronic second generation, all the future generation heaters will have this kind of nomenclature to designate the heater. So the first three components of this nomenclature will identify the heater name. So of course H will be hydronic, will identify the sizing or the heater class or the size of the heater. So yes, we have these small, medium, and large classes. So if the heating output is anywhere between 4 to 6 kilowatts, then it will be designated as a small heater. Between 8 to 12, it will be designated as a medium heater, and anywhere from 24 to 35 would be designated as a large heater. Number 3 would designate basically the generation. Then it's followed by 3 more components of the nomenclature. The first part identifies the fuel type, just like in case of the electronic heater. The next number will allow us to identify the maximum output of the heater in kilowatt, and it can range from a 4 to a 6 to 8, 10, 12 kilowatt range. This 2 over here is a typo, so that should not be there. So it should begin from a 5 kilowatt or a 4 kilowatt all the way up to a 35 kilowatt range. Then we have the designation for the voltage rating. So either it's a 12 volt heater or a 24 volt heater. Of course, I skipped over this letter. This letter will indicate the version. So E would stand for the economy series heaters. This is generally the 12 volt versions of the heater. Then the L would stand for long life versions. These are the commercial versions that has up to 5,000 hours rated life. And then the letter A would be the automotive, which is basically mainly meant for OEMs in Europe. And then finally, the tail end of the nomenclature would further specify the version by spelling it out, whether it's an economy, OEM, or commercial towards the end. So this is a complete designation of the Hydronic S3 heater, and also of any other heater, future generation heaters that will be launched. So in the next slide, you should see all the different models that are currently available here in North America. I'm just going to quickly check to see if we have any questions in the chat. We don't, so I'm going to move forward with our presentation. So we can see the Hydronic S3 CS version of the heater. We have the 12 volt economy with the fuel metering pump and the water pump available. That's the standard version. And this is the diesel variant. And of course, we have the gasoline variant here, because now the letter D has been substituted by the letter B, which is benzene. And then we also have the 24 volt version with the fuel pump and water pump. And the model that we make available is the 6 kilowatt version, which is basically approximately, if you look at the actual output, it's somewhere in the range of 5.6 kilowatt, but we designated at 6 kilowatts anyways. So these are the latest versions of the heater, the CS versions of the heater. And then for pickup truck applications, we also have the CL versions of the heater for those applications only. So yes, we have the gasoline version, 12 volt, CL version available. And as you can see, all of these heaters come with the fuel pump and the coolant pump included with the bare heater. We have the diesel variant, CL version. And then we also have the diesel variant, but with a pressure-resistant fuel pump. This PRMP stands for pressure-resistant fuel pumps. So these are used in applications where you have to tie into a fuel line which has higher pressures. And this would be an ideal choice for those kind of applications. And then We also have the CS version of the heater. This is the very similar to what we see here. The only difference being instead of just a regular fuel pump, now comes with a pressure resistant fuel pump, and this is again used for pickup truck applications. So overall, these are the heater models currently available for the North American market. But if you were to look up the partner portal, you will find that there could be many other models, but they are mainly used in the other markets around the globe. So when we talk about the CL version and the CS version, what is different? Of course, the CAN version of the heater is different. So the C letter, the letter C stands for CAN. The letter L stands for LIN bus, and it's an indication of the communication protocol used by the heater. And whereas over here, the C obviously stands for CAN, and the S indicates the S plus signal option. So that is what differentiates the two heaters. Also, when we look at the CAN interface is not exactly the same for both heaters. As we know from the specification slide that we saw earlier, the CAN interface for the CL version is only utilized for diagnostic purposes. That means you can connect your easy scan and then communicate with the heater. Whereas on the CS version, the CAN is able to not only communicate with the diagnostics, but also with the controller, the Easy Start Pro controller, and then all other peripheral devices like Easy Fan and Easy Start Web. These are all other devices that are used in Europe predominantly. So yeah, it's a much broader CAN protocol as compared to the very limited CAN that's on the CL version. So that's the difference. Because the CL version could only be operated using the LIN, L stands for LIN, to activate the heater, the only choice of our controller, standard controller, was the Easy Start Timer. And for those of you, and you probably are familiar with the Easy Start Timer, you only need basically 3 wires from the Easy Start Timer to connect to this heater. So one would be your main power. Second would be the ground that comes from the heater harness or from the ECU itself. And then the third would be the communication wire, which is basically identified by the blue wire with the white trace on it. So in the past, our harnesses used to have the blue-white as the standard in the main heater harness. So it was a simple matter of connecting blue-white to blue-white on the controller, the Easy Start Timer, and everything was good. But with the new heaters, the harness colors have changed slightly, and the change in color is that instead of using the blue-white, we have switched over to the yellow. The yellow is mainly used, it can be used on the CS version of the heater to provide an input to the heater using the S plus signal so as to activate the heater. But because the harnesses now there's no 2 different harnesses, the same harness with the yellow wire is still used for the CL version. You have to keep in mind that when you install a CL version heater, and then if you're using an Easy Start Timer, on the timer side, it still remains blue-white, but that blue-white now will connect to the yellow on the main harness. So this is an important note that you must keep in mind. As I mentioned, the CAN is totally different. So because the CAN is different, then the motor is not interchangeable. The fan motors are not interchangeable across both the heaters. So if you decide to switch the ECU of a CL version with the CS version of the heater, then you would have to also replace the motor itself. So now let's take a look at all the different parts of the heater. So from the design point of view, I mean, the basic principle of operation point of view, I would say the heater is exactly the same as compared to the previous generation. Yes, every heater will have a combustion blower motor. Every heater will have a heat exchanger. Every heater will have a water pump, a fuel pump, and so on. So all those parts are, again, just the same. It's only newly designed, looks different, etc. But the principle behind, or the principal function behind those parts still remain exactly the same. So this is an overview of the different parts. This is a nice little cutaway picture of the heater that shows the internal parts, and a lot of changes has gone into designing the heater. As you know, the combustion chamber is totally redesigned. The fan has been completely redesigned. The glow pin placement is now totally different, and so on. But we will take a look at each one of these parts one at a time in the following slides. So let's take a look at our sensors. So what we are seeing here is the complete sensor assembly. So as part of the assembly, we have also the water inlet sensor and the water outlet sensor as part of the assembly. This is a very similar function as the previous heaters, where instead of calling them as an inlet and outlet sensor, we used to refer to them as a coolant sensor and an overheat sensor. So the functionality remains the same, but it's the naming is slightly different. Also, these sensors are now part of a much larger assembly, as you can see. So in the event these sensors go bad or something like that happens, then the entire assembly can be reordered. And the positive or the good thing about that is that it eliminates the need to unpin the terminals, having the right terminal release tools, etc., which was oftentimes the root cause of many of the issues. So by eliminating that and providing the entire assembly as a whole makes much better sense, and also avoids any kind of rework, etc. So yeah, these sensors are placed, as you can see, on either ends of the heat exchanger. So one is for the inlet sensor, the other is the outlet sensor. Next one is the flame sensor, which is part of the same assembly. As you can see, the flame sensor is an important sensor because it helps the heater in detecting the ignition and the starting up, helps, basically helps with the startup process. Like always, the sensor on the hydronic heaters, it is used to measure the temperature of the exhaust gas, and to get the maximum temperature measurement, it's usually placed right next to the exhaust port. And on this heater too, it's exactly the same. It's basically simply sitting in the path of the hot exhaust, and then that way it's able to get a much optimized measurement. What has changed is, though, in the past, this sensor would be in a position where it would also be kind of almost surrounded by cold coolant, which is circulating around the heat exchanger, and the cold coolant would influence the temperature rise of the flame sensor, and thereby that would play a huge part in the successful start of the heater. So in the third generation heater, they have made a concentrated effort to move it back and separate the coolant jacket versus the exhaust port. And so now on the new heaters, this flame sensor is under no influence by the cold coolant that is circulating around. So, which automatically means you have a much higher reliability on these heaters. As you know, these heaters were introduced, I would say, almost a little over 4 years ago or more into the market, and we have been monitoring the issues in the field, And what has been really, really remarkable is that this heater has very less issues being reported where someone comes and says, my heater would not start because it's 10 below or 20 below. I mean, the reliability factor is amazing on these units. And one of the reasons for that is the placement of the flame sensor. The fan assembly itself, as you can see, it's an EC motor. It has a lifetime of 3,000 hours. Again, depending on the variant, whether it's a 12 or 24 volt. Officially, yes, you can achieve up to 5,000 hours. Well, a couple of things that have also changed in the design is the gap between the blower wheel and the machine surface, which is a very important gap to be maintained. And this is basically the same for the first and the second generation heaters also. But what has changed is the size of the gap. So it's been reduced to almost 0.16 millimeters. To give you an idea, the previous generations, it was almost double of this. So it's a much smaller gap. And one of the things that could happen because of a smaller gap is that you may have dust and dirt and debris get into it. And if that happens, then it can cause a problem. But on this heater, that's never a problem because the entire motor is now encapsulated. And also, there are certain protocols to be followed when you open and close or tear down and dismantle a heater and then reassemble a heater, which will allow for those IP protection classes to be maintained. And one of the things that is recommended that needs to be done anytime the heater is taken apart is that the cover that sits on the blower, that needs to be replaced every time you separate the two. It's not that it gets damaged. There's no visual indication of damage when you separate the two parts, but the seal part of it is compromised. So we always recommend that this cover should be replaced. Now, should a customer decide not to follow the instruction and reassemble it, without replacing it, it is possible the IP protection classes will be compromised, and because of the lower gap now we have, that can cause major issues. Fortunately, like I said, because of the increased reliability of the heater, the events that lead to tearing apart a heater are very few. So even if it was the case that someone did not replace the cover, those kind of cases would be very few in the field as of now. So in the next slide, you will see the couple of images of the combustion chamber. So as you can see, now we have switched to the sheet metal type combustion chamber. In comparison, our previous generation heaters used to have stainless steel combustion chambers, and we used to actually, be proud of the fact that it was a stainless steel, much more rugged, could not be destroyed or crushed, etc. But because of the high price of the materials, we needed to make sure that while we offer better features on our heaters to our customers to make it competitive, we also wanted to keep the price of the heater in check. And one of the ways to do that was by switching to the sheet metal chamber. And if you were to just, casually compare this with competition, you might say, hey, it looks the same, but it's not really the same because a lot of engineering has gone into the design. This is basically now a high temperature resistant material, laser welded together, a lot of close tolerances between how the evaporative mat is placed in proximity to the glow pin and the depth of the glow pin, etc. A lot of engineering, I would say, that has gone into this to make it a whole lot more reliable if you were to compare it to any other sheet metal type combustion chambers that may be in use elsewhere. The evaporative mat is what basically assists with the vaporization of the fuel. This is not a removable part, so which means you cannot just remove the mat and replace it with a brand new one. In the unlikely event that you have to replace a combustion chamber, then the entire combustion chamber would need to be replaced. But once again, in the last 4 or 5 years, we haven't seen any kind of complaints that have led to such kind of major repairs in the field. So that's definitely encouraging. The glow pin, yes, the pin is still made of ceramic like before. As you can see now, a little bit much better quality, so we have a much higher lifetime in comparison. So the previous generation heaters would achieve a maximum of somewhere close to 18,000 ignition cycles, but that's been extended almost 5 times as much with the new glow pins. Also, a very important change that you will see is the fact that these glow pins now do not have any kind of threading on it, which means you don't have to screw the glow pin in or tighten it with a specified torque. It simply is slipped into position and then held in position by the grommet. That's part of the glow pin assembly. So by eliminating the threads, we are eliminating the chances of broken glow pins and someone not using the right tool and over tightening, etc., etc. The function of the glow pin still remains the same. It's meant to ignite the fuel air mixture, and that's basically what it does even on this heater also. The heat exchanger, as we know, has been modified. A lot of thought and engineering time has been spent on making sure that the hot part of the heater is kind of isolated from the colder parts of the heater. And also, while making those kind of changes, they also wanted to ensure that they are, from the coolant flow perspective, that we are achieving the maximum flow rate with less restrictions, and also a very much improved transfer rate. So the design of the heat exchanger has taken an account of that and provided for less restrictive flow rate of coolant, better surface or larger surface area for improved heat transfer rate, and then also, like I said, thermal decoupling of the colder electronic components from this part itself. The fuel pump is new. This is almost, I would say, almost the same like the second generation Hydronic heater fuel pump. It has been redesigned externally. The only change you will find is the electrical connector is now on the inlet side of the fuel pump, versus in the past it used to be on the outlet side of the pump. But internally, the components have been redesigned, resized, changed in materials, etc. And then also it's now electrically controlled. So this leads to a whole lot quieter operation, higher efficiencies, and low power consumption, and also to mention increased reliability, even under cold weather situations. The ECU, as you can see, is a very important part of any heater, and so is with this heater. Of course, we have a double-sided PCB board with all the electronic components, unlike in the past where we used to have some sort of a potting material that covers all the main components on the board itself. If you were to open this, you would simply see a bare PCB board with all the components. You're not supposed to be opening it. This image over here is just as a representative picture. It's not indicative of, hey, you need to separate the board itself. It makes no sense, because if you have a bad ECU, then there's no repairs possible, number one. And number two is, if you order a replacement, it comes with the actual framework of the entire ECU. So this is what it looks like, but it's in this plastic housing, so it's part of the ECU itself. On the ECU, yes, when you look closely, you'll notice that there are tabs on the bottom. This is for the production process where they insert the board and then they complete the task. So just because the tabs are visible does not indicate that it needs to be opened or removed. On the opposite side, yes, there are 4 additional tabs, and this basically what locks into the fan assembly and the top cover. And these would need to be released. And we have a slide that comes up that kind of goes over some more details on how that can be achieved. If you do order the ECU, then the ECU the kit will come with the ECU itself. All of the screws that are required to fasten it or complete the mounting. There will be a cover plate that sits on the side over here, very close to the connector. And then included in the scope of supply will also be this cover for the motor. The reason being, and I think I did not mention it in the previous slide, is that the fan assembly plunges directly into the ECU and makes direct contact. There is no other harness or terminals in between. So this cover is included in the scope of supply. So at any point in time, if you're tearing a heater apart, then that cover automatically is included so that you're then replacing it. However, this has to be calculated in a way where you tear apart a heater only after you're 100% sure that you have a component that needs to be replaced. And if so, then that component replacement kit will include the cover. The cover by itself is not a part that can be ordered, unfortunately. And then finally, the part is the coolant pumps. So we have the 12-volt coolant pump for the 12-volt series heaters. This is the regulated pump. So there'll be 3 wires. Like I said before, it allows for much quicker heating of the coolant by regulating the coolant pump rate and reduce power consumption. On the 24-volt version, yes, we have a slightly different pump. So the connectors, the harnesses, the connectors are slightly modified. You will see it when we look at the wiring diagram. But this is the newest pump that they have out there. And compared to the previous MES pumps, I mean, this has a much better increased lifetime. And these pumps can also be used as a standalone in any other application. It's not heater specific. So here on this slide, you can see all of the different parts and the scope of supply of those parts. So yes, this we had seen this image before. That's the ECU. We also have the sensor assembly, and this includes both the water inlet and outlet sensors, and also the flame sensor, and also the ground cable that connects to the ECU or grounds the ECU. And all of this is pre-assembled into the connector itself. So pretty much what you would need on this connector would be to unpin the glow pin. You'll have to unpin the glow pin and then pin the glow pin back into the new connector or the replacement connector. The glow pin by itself also is available as a spare part, and each of these parts includes the cover for the motor, as you can see, and all of the relevant screws that are required to mount it in place. And then, of course, we have the components shown below. That's the combustion chamber. Once again, it comes with the main combustion chamber assembly, the gaskets that have to be used in between the combustion chamber and the heat exchanger. And then also we have the grommet that will sit on the fuel line as it exits. So from point of view of special tools, you can see these plastic wedges are designated as special tools that will assist with the separation or release of the tabs. So this is called as a control box dismantling kit, and that's a part number. It'll have 3 pieces, and the way it is supposed to be done is that the shorter pieces, number 2, has to be inserted on both ends into the tabs to kind of pry it loose from the lock, and then the part number one will be then inserted towards the back end of the assembly, and then it would be used to release the tabs again. And once you have all three in position and with gentle pressure, then yes, the fan cover will come off, and that will allow us to remove this completely. Now, it will still be attached to the front end, and the front end can only be released once you have the cover for the sensor removed. This cover on the front end is basically what also locks down the coolant ports. And once again, if you were to remove the cover and the coolant ports, then you would have to replace the O-rings around these ports when you reassemble the heater. From the electrical connectors, you can see on the bottom of the ECU, we have three connectors. We have a 3-pin connector, so that's the one for the water pump. We have three because the water pump is now regulated. And I did mention this before. You can switch off the regulation should it be preferred, but by default it comes with the regulation activated. Then we have the main signal connector. It's a 6-pin connector, and you can see the pinouts. Pins 1 and 6 are for the fuel pump, plus and minus. Then pin number 2 is the input signal, or it can also be for the CL version of the heater. It can also be used as the LIN signal input. Then pins 3 and 5, these are the CAN high and low connections. And then the 4 is the output, the analog output that can be utilized to switch on, other pieces of equipment like a blower motor or a magnetic valve or anything of that sort. And then we have 2-pin connector, which is mainly the main power supply connector. So water pump connector, power supply connector, and then the signal connector. These are the 3 connectors on the ECU. So it's a very simple connection. So from a controller option, the Easy Start Pro is only for the CS version only. And as I mentioned before, this is because the CS version of the heater can communicate only over the CAN bus or the S Plus. So Easy Start Pro is completely for CAN bus communication only. We cannot use the Easy Start Pro on the CL version because in the CL version of the heater, the CAN protocol is only used for diagnostics. The Easy Start Timer, on the other hand, can be used across both CL and CS version. So on the CL version, obviously the LIN part is being used to communicate with the heater. That is the blue wire with a white trace on it, blue and white wire. But then in the CS version, how would you use it? With an Easy Start Timer, you would use the S Plus option. So you will send out a 12-volt signal from the Easy Start Timer to the CS version of the heater in order to activate or deactivate the heater. But then when you do that kind of setup, of course, you will lose features, which means, yes, the Easy Start Timer will be able to switch on the heater, switch off the heater, but beyond that, it cannot do anything else. I mean, it cannot communicate with the ECU to read fault codes or adjust any kind of parameters, etc. None of those is possible using the control itself. So you would have to then rely on the Easy Scan tool to do that. The other options available are analog controllers. So S Plus signal for just for the CS version of the heater. And then we also have the Wi-Fi controller. So let me see over here. Okay. Just going to go back to my presentation. Yeah. So the Wi-Fi controller, as I mentioned, this is a third-party Wi-Fi controller that was designed based on heater CAN bus protocol, so as to be able to communicate with that. So it's an option that is available. So from a heater operation standpoint, you will see the logic still remains almost the same. Just like in the previous generation heaters, yes, there will be a parts test that would be initiated right as soon as you switch on the heater. Then there'll be a kind of a sequence of activation of components. Of course, the water pump will start up and remain on till the end of the whole cycle. The fan starts up at lower speeds. The glow pin will be preheated. And then eventually the fuel metering pump will be activated. And once all of that comes into play, the fuel that's vaporized within the main ignition chamber will be ignited by the glow pin. So now your fuel starts to burn, and then that is then detected by the flame sensor. So the ECU knows that the heater has made a successful start. And once that happens, the glow pin is then switched off after a stable flame has been established. And then the heater would be in what's called as an operational state or regulation mode, if you may, where the heat output would be constantly adjusted based on the optimum temperature that needs to be maintained. Unlike the electronic heater, where you can specify what the target temperature should be, the target temperature is prefixed into these heaters at the factory. So based on what I've seen, it should be approximately, I would say, close to 700 and I would say somewhere around 170 degrees Fahrenheit. But then that can change. It can change from heater to heater. The only way you can tell is if you were to connect it to the EasyScan diagnostics. Now, one of the changes between the third generation Hydronic S3 heater versus the other generation is that some of these parameters can be modified. Again, it requires the use of EasyScan, and also it requires a much higher level of access permissions. So once someone has that, then it's possible to modify some of the parameters. There have been discussions to extend some of the privileges to our customers. So maybe in the future, some of you, especially dealerships, may have that ability to do it on your end also. So the control strategy, as you can see, is defined in this slide. So one of the things, of course, has changed over the previous generation is the fact that now we have an infinite number of heat output levels because the heater has a variable output. So rather than switching from 75% to 50% and then back again to 75%, I mean, the heater can adjust in much more smaller steps. Also, the heater is able to adjust to a much lower threshold from an output standpoint of view because the output has now been lowered from 1.3 kilowatt to from 2.3 kilowatt to almost 1.3 kilowatt. So as long as the output remains above these low numbers, the first one is for the diesel variant, the second one is the gasoline variant. As long as the output remains above these numbers, the heater is still running. It's only when it drops below this, then the heater is then forced to switch off. So by reducing the lowest output, we are kind of reducing the number of times the heater would be forced to switch off and then restart. So because always, whenever you switch on the heater or whenever you restart a heater, that's the most I would say, a critical time where most of the failures would happen. So by reducing the number of such restarts, we are kind of eliminating the possible chances of failure. So that's basically what's mentioned over here. By reducing the minimum power output, the number of restarts can also be reduced. So with the 24-volt version of the Hydronic S3 heaters, there is what's called as a damping element. This is required for all installations, and the whole purpose of this is to reduce the vibration load on the casting on the heater casting part, and especially you could have increased vibration when the mounting holes are not on the same level. So this is a requirement. It's included in every 24-volt heater kit. So make a note of this, especially if you are installing 24-volt heaters. The harness, this is again based on the same kind of design principle as the Aerotronic harness that we saw 2 days ago. This is the North American version of the harness. The European version of the harness is different. It's much more shorter. The European version is much more shorter. The European version of the harness also does not have a very good quality of protection around the harness itself. It's more like a cloth that's wrapped around it, whereas you have a much higher quality, reliable plastic sheath around the North American harness. And also, the design has been, design of the harness makes the heater installation here very easy. So you can see the main harness has the two connectors. One is the 2-pin power connector, and the other one is the 6-pin signal connector that will plug into the bottom of the heater. And then depending on whether it's a 12-volt version or a 24-volt version, you'll have this coolant pump harnesses that will connect to one end on the coolant pump itself and the other end on the heater side. And because the coolant pumps are different for 12 and 24 volt, that's the reason for these two separate harnesses. Depending on the kit that you order, you'll get either one of them included. As you can see, just like with the Aerotronic, we have these branches of the harnesses. So this one is the diagnostics harness, and this is what connects to the Easy Scan tool. It'll have the end cap with the small little resistor already pre-assembled on it, and when you do Easy Scan diagnostics, that's where you're going to connect to. From the termination resistor point of view, we have there are resistors embedded in the harness, and they're clearly labeled as do not bend. So when you do the installation, it has to be ensured that they are not bent and broken, etc. The second branch of the harness is the fuel pump harness. Just like in the Aerotronic heater harness, it's kept short with the older style fuel pump connector pre-assembled onto it, and the purpose is to utilize the adapter harness for the fuel pump that comes pre-installed with on one end with the new style connector, so the customer does not have to worry about having the right tools to do the job. So all you do is plug this into your new fuel pump and then run it all the way back to the heater, cut it to length, and then assemble the rest of the connector, which is the older style connector, onto it, because the kit comes with the connector and the terminal and the weather seals. And then that end of the harness then finally connects to this end of the fuel pump harness, completing the installation for the fuel pump. The next branch of the harness is the one that will connect to your Easy Start Pro controller. Yes, we have the Deutsch connectors with the terminating resistances. This is basically will be removed from here and moved to the further extreme of the end of the Easy Start Pro harness. We'll see that coming up in the next slide. We also have the analog harness that's provided over here. You can see this is basically for switching on the heater using an S plus signal, if you may, or if you want to connect a LIN bus controller like the Easy Start timer, then this would be used. And then we also have the battery harness that will run all the way to the main batteries, and then you have the kit to complete the installation. That includes, depending on the voltage, you'll see the fuse holder, and the eyelets and the terminals, etc., all included in the kit. So fairly intuitive, very easy to install harness, main harness assembly. So like we see here, it does not include the rest of the controller, CAN bus controller harness, because the CAN bus controller harness comes with the controller kit. And that's the part number for the Easy Start Pro controller kit that includes the CAN bus harness. We already know this from a previous webinar on Tuesday, where we talked about how to connect this. So yes, one end of the harness will have all these connectors pre-assembled, so you would not have to worry about it. All you would do is remove the cap on the main harness on the CAN bus harness, and then move it all the way till here. This 4-pin black connector plugs into your Easy Start Pro controller harness, and then you would run the cables or wires all the way back to where the heater is, or all the way back to this end over here, and then cut it to length, and then crimp the terminals that are provided in the kit. Insert the terminals, making sure you're aligning the right colored wires on both ends, and then you would, after inserting the terminals, you would lock it in and then connect the two together. So it's fairly simple, easy to install. Controller options, yes. CAN bus options, this is for the CS version of the heater. LIN communication is possible. Also only on the CL version of the heater, as you know. And then the S Plus is for the CS version of the heater, where you could use any of these analog controllers, because all it does is it provides a 12-volt signal to the heater. Like in the case of the Hydronic, yes, you could have multiple controllers. You could have the CAN bus controller and the S Plus combined for the CS version of the heater. But like I had mentioned in that webinar, the priority will be for CAN bus, and then the next level priority would be for the analog devices when it comes to operation of the heater. Excuse me, this is the Easy Scan connection. This is the exact same deal. You remove the cap, connect the diagnostic adapter, the 4-pin diagnostic connector to this end of the harness, and then you connect the Easy Scan adapter to the computer and then get on with the diagnostics. Once you're done, you disconnect the 4-pin adapter and then replace this cap with the terminating resistor on the end cap there. Just like on the Hydronic, yes, up to 10 fault codes can be stored in the ECU memory. There is also additional data that is stored in the ECU about the codes, and especially the last time the code has happened, it will store information about the operating status of the heater, including what stage the heater was operating at, what was the voltage being recorded, what was the temperatures being recorded, etc. So all that plays a very important role in the analyzation when you review the fault code and you're trying to assess exactly what may be the probable cause of that failure. This data is very invaluable. Like on the Hydronic heaters, yes, these heaters also will have a mirror memory that will store the codes that can be accessed only by the factory warranty personnel. This is done using Easy Scan, and this is especially when someone deletes the codes and and we would like to take a look at it, then this definitely helps. The code formats are different, as we saw in the electronic webinar. Now it's the standardized automotive format. The meaning of the code, however, the instructions, troubleshooting instructions are identical. No change there, but it's only the format that's now modified. Just like on the electronic heaters, more detailed, complete, comprehensive description of these codes, troubleshooting and repair instructions are all in the manual, and this can be downloaded from the Eberspaecher partner portal. As far as ECU lockouts, yes, it's possible. Yeah, you can your ECU will lock out if there is more than 10 consecutive failure to start by the heater. So each time the heater fails, and then just like on the electronic, the heater will make up to 2 start attempts before it fails. And if it does fail after making 2 start attempts, the code P0012A will appear. And once this happens more than 10 times, now the ECU locks up, and then the lockout code would be P0012B. And same is the case with overheating events. So any of these overheating event that produces these codes, P00114 or P00115, after 10 such events, then the ECU will lock out with the code P0011A. Unlocking the ECU will require Easy Scan diagnostic tools or the Easy Start Pro CAN bus controller. Yes, you can unlock it, but like I mentioned before, if you do use the Easy Start Pro to clear the codes, then all the information would be lost. Whereas when you use an Easy Scan tool, you would not have to clear the codes to unlock the ECU. You would only reset the counter where it counts the number of times the event has happened back to 0, and that resets, basically unlocks the ECU. This last line over here is not applicable on the hydronic heater. It's there, I need to remove it, so just ignore the last line. You're not able to unlock the heater just like the electronic heater, where if you had an overheating lockout event, you can disconnect the power and then reapply the power and then unlock the heater. That is not, that feature is not available on the hydronic heater. On the Hydronic S3 heater, these are the current kits that are available. So in our product catalog, which was updated in June, you will see all of these kits listed. You'll have 12 and 24 volt kits. You'll have the boxed kits, unboxed kits. You'll have the diesel kits, the gasoline kits, etc. So all of this information can be found in the manual, along with the entire kit number. And also against each kit number, it will identify what is included in the kit. And you can see for most kits, or almost all of the kits, the fuel pickup pipe is not included. The fuel pickup pipe has to be ordered separately. And in some of the kits, you can see even the controller has to be ordered separately. And in some, you can see will include the hoses, the coolant hoses, and some it won't. So make a note of that when you order the kit. It's not one size fits all. Depends from application to application. And if you do have questions, don't hesitate to reach out and get in touch with us. So for the pickup truck kits, we have a special section in the product catalog that identifies all the different kits that are available. We have the gasoline version of the kits, we have the diesel version of the kits, and then we also have the vehicle-specific versions of the kits. So you can see we have the installation kit for the Dodge Ram, we have the GMC Silverado kits available, we have the Ford kits available. So, excuse me, specific pickup truck kits are available, and also non-specific ones are available that can be ordered. So all of this information can be found on the product catalog, and the latest version of the product catalog can always be downloaded from our partner portal the Eberspaecher partner portal. All right, moving forward, standard warranty. Excuse me. As you can see, the standard warranty on the S3 heater is 2 years or 2,000 hours, so that has not changed much. From the point of view of what parts are covered, this slide over here, this portion of the slide will give you a good indication of what parts are covered under warranty. So pretty much most of the parts are covered. The ECU, the fan, the harness, the lead harness, which is basically the harness with the sensors, the glow pin, the combustion chamber, the O-rings, sensor O-rings. So pretty much all parts are covered under warranty. And then also parts that don't require the entire heater to be removed. Those parts are also mentioned over here, and that's included in the scope of warranty coverage. One very important thing to note that do not replace whole heaters in order to fix a problem, because those then will not qualify for warranty. Warranty always recommends what's called as an always repair policy. And if you do have questions or concerns, please don't hesitate to get back to us. From recommended maintenance and service, very similar to what you would do on the Hydronic heaters. So do a visual inspection of the heater once every year. Operate the heater once every month for 15 minutes. Very important to run the heater once every month, even during the summertime. Replacing the fuel pump inlet side filter, this is recommended. Verification of the controller settings, and finally reviewing the fault codes in the heater memory. Thank you for watching. Please contact us if you have any technical questions. Also, please remember to provide us with your feedback and comments. Thank you and goodbye.